So today we're going to talk about a different way to measure angles, and I always like to compare it to how we measure temperature, right? We measure temperature in what? What's the most common way? Fahrenheit, okay? Yeah, so in degrees Fahrenheit, right? In Fahrenheit, but you can also measure it in what? Yep. So like if somebody told me, oh, it's going to be 60 degrees Fahrenheit today, I would know how to dress for the weather right away. But if somebody told me it was going to be 15 degrees Celsius, I would need to do some conversions first. Okay? Are some of you good at knowing what the Celsius is?
5 divided by 9.
Yeah, there's the 5 nines plus the 32. Yeah, but you'd have to do the calculation, right? Okay. So when we're learning a new way to measure angles, at first, it's going to be like I'm talking to you in degrees Celsius, and you're not going to know what jacket to wear, but we're going to practice, okay? And before Memorial Day, you're going to know radians just like degrees, okay? All right, so a radian is just a unit of measure. It's another way to measure your degrees. Okay, so a radian is just a unit of angle measure, and it is based on the arc length. Okay, so write this down with me. Put down your straight edges if you have them. You're not going to use those yet. Are you spinning your straight edge like a helicopter? Then yes, it was. Then you were one of the people I'm talking to. Okay, so this is another no calculator section. You're going to want to write that at the top because you are going to have a no calculator portion of your test, and you are going to have a calculator portion. Okay, and then do any of you remember the arc length? I honestly don't expect you to. How to calculate the arc length from geometry. I'm going to show you the formula to jog your memory. It's your angle over 360, but it has to do with the pi. We're going to talk about the pi. So when you did the arc length in geometry, you had your angle measure divided by 360 measured by 2 pi r, because 2 pi r is the distance around the circle. Okay, so what you were doing is you were measuring part of the circumference times an angle divided by 360. Okay, so the circumference of a circle that has a radius of r is 2 pi r. Okay, so if you have an angle representing one complete clockwise rotation, that is going to measure 2 pi radians. And we are going to use the fact that 2 pi radians is equivalent to 360 degrees to convert between radians and degrees. All right, so I want you to read through the key concept box there. So when you are converting from degrees to radians, okay, you are going to multiply pi radians by 180. Okay, so you are going to multiply pi over 180 degrees. And then if you are doing radians to degrees, we're going to multiply by 180 over pi. Okay, 180 degrees over pi. Okay, so for the 180 degrees, okay, this part here is 180, which is the same as pi. I'm going to email tech help. All right, and then when you are multiplying, okay, I told you that we were going to use that 2 pi radians is equivalent to 360. So when you reduce this, 2 goes into 360 how many times? 180. So that's where this conversion is coming from. You can think of it like a ratio. Pi is 180 degrees. Okay, 2 pi is equal to 360 degrees. Okay, and then our 2 pi radians, what they have here is that 360 is equal to 2 pi. That's what we have here. And then I also want you to know that 0 degrees, okay, is equal to 0 radians. Okay, so degrees and radians are both 0 at 0. 0 degrees is equal to 0 radians. Okay, so when we're doing this, it's important that we have the correct notation. So if there is no degree symbol, if there's no degree symbol, then the value is in radians. Okay, you can see here they wrote out radians, pi radians, 2 pi radians, 0 radians. You do not have to write out radians every time, because if there's no degree symbol, then it's in radians. Now, often it's going to have the pi symbol if the unit is radians, but it does not have to. Okay, so anytime you are writing a degree, you have to have the symbol. Okay, your degrees need the symbol. Okay, all right, so we're going to write each degree measure in radians. And because this is no calculator, we are going to leave these as exact values with pi. All right, so we're going to start with negative 60 degrees, and we are going to convert that. So if you have negative 60 degrees, we are going to multiply by 180, or sorry, multiply by pi over 180. Whenever you have the degree symbol, you want one in the numerator and one in the denominator so that they cancel. And just like when you're multiplying fractions, you multiply straight across, and then you can reduce. So it's negative 60 pi over 180. When you're reducing, what's the first thing you're going to divide by? How do we get rid of the zeros? Yeah, you can divide by any of those. I'm just saying commonly we divide by 10 to cancel out the zeros. That's what I'm doing when I cancel out the zeros. And then 6 goes into 18 how many times? Yep, and it goes into itself once. So negative 1 pi is the same thing as negative pi over 3. This is going to be your value. Yep, the negative can be written like this. Yep. Okay, so negative 60 degrees is negative pi over 3. What does that mean that 60 degrees is? No. So if negative 60 degrees is negative pi over 3, then positive 60 degrees is pi over 3. Yeah? All right, so I want you to do part B with your cable partners, with your row partners, okay? Well, I want to get that in with that. Okay, so then once you get that, I want you to check with your row mates. All right, do we need it any more time for that? What do we get? Good. Okay, so when you're doing this, if you get to a point and you're not sure if it reduces anymore, you can always think of it as a factor tree, right? 25, you have 5 and 5. So it's 1, 25, and 5 that go in there. For 18, 1, 18, 2, and 9, 3, and 6, they don't have any common factors. You can't reduce it. Okay? All right, now we're going to go the reverse way. So we're going to write each radian measure in degrees. So your final answer needs to have the degree symbol. Again, sometimes they would just write 2 pi over 3, or they'll write 2 pi over 3 radians. If there's no degree symbol, it is in radians, okay? I'm going to want to see like what you're multiplying by, yes. Okay, so when you're doing that, the 2 pi over 3 is going to be multiplied by 180 degrees over pi. Okay, so yes, I want to see this step. Okay, and then if you want to do the crossouts, you can. Okay, and then I would do 180 divided by 3, because how many times does 3 go into 18? Yep, so this becomes 60. And then see how you would multiply straight across? 2 times 60 would be 120 degrees. And so this needs to be your final answer. Will you just double check your degree symbol? Yeah, because then that would mean 120 radians. So the other way you could do this is you could go straight across at the beginning. So you could also do 360 divided by 3. And again, you would get 120. Either one of those methods are fine. Oh, and then speaking of going to radians, I wanted you guys to write in here. This showed you what 1 radian is. Okay, so this value, this theta value, where it says theta equals 1 radian, visually this is 1 radian. What's that? No. Your 1 radian is in between 0 and 90, but this is going to be a little bit closer to 50-ish, but it's not an exact value. All right, and then you guys are going to do your value for B. You have negative 7 pi over 2. I'm going to show you what my radius is. Okay, so you should be multiplying by 180 over pi. The ones that you guys are doing, you will have your pi's here so that they cancel out. And then what I would do is 180 divided by 2, because what's that? 90. Okay, so if that's 90, when you're multiplying, just do 7 times 9, which is 63, and then you're going to add the 0 on there, so negative 630 degrees. If you didn't have a pi and you had to convert it, that would have to be on the calculator section. Okay, so you guys were just asking me a good question, like what is 1 radian in degrees? Well, to find that, we would take the number 1, multiply it by pi over 180. Oh no, I'm in degree mode, so I have to change it to radian mode, or I have to get my other calculator so I can do it. Yep, so you can change it to radians, and then it'll say RAD on the scientific one. So 1 times, and then we would do 180. So this might be to be in degrees. Yeah, so 57.3 degrees. Yeah, that's kind of hard for you to see. Okay, so see, it's close to 60. It's about 57 degrees. Okay. All right, and then we are going to do just a quick review from yesterday, which is how did we find the coterminal angles yesterday? So this was the last part of your homework assignment. What did we have to do to find coterminal angles? Yep, we got to add or subtract 360. Okay, so I want you to write that down, plus or minus 360. That's what we did yesterday. Okay, so for the prediction, it says, how do you think we'll find coterminal angles in radians? So if yesterday we did this in degrees, we added or subtracted 360 degrees. If we're in radians, what's the equivalent? Plus or minus? Not pi over 180. 2 pi, yes. Okay, because remember one of the first things we talked about is 2 pi radians is equivalent to 360. So 1 full time around the circle is equal to 2 pi radians, okay? So we're going to find the measure of a positive angle and a negative angle. So one has to be positive, one has to be negative. That's exactly what we did yesterday. And they have to be coterminal with each given angle. Okay, so the first one we're going to do is 4 pi over 3. Okay, so all we have to do in order to be successful at this is know how to add fractions together. So if we take 4 pi over 3 and we add 2 pi, what we need is a common denominator. Right now, the denominator of 2 pi is 1. So if I want it to be the same as this denominator, I have to multiply by what? Yep, and you have to multiply the top and the bottom by 3. Okay, so you have to multiply 2 pi by 3 and 1 by 3. So this is going to become 4 pi over 3 plus 6 pi over 3. Once you have practiced this, you're going to get really good at this. You're not going to have to think of it like this because what is 6 pi divided by 3? Just 2, right? 2 pi. So you can automatically convert that by doubling it, or in this case, sorry, tripling it. And when you add them together, it's just like you would have 4x plus 6x. So 4 plus 6 is 10, so this is going to be 10 pi over, and then what is the denominator? 3. When you add fractions, the denominator stays the same. Okay, so this would be a positive angle. Then to find the negative angle, we can subtract 2 pi. And instead of writing out the minus 2 pi, I already know the denominator should be 3. So you can just start by saying minus 6 pi over 3. Because 6 pi over 3 is equivalent to what? 2 pi. Okay, so this is going to be, what's 4 minus 6? Negative 2. So it'll be negative 2 pi over 3. And then we have 1 positive and 1 negative. Okay, so we are all set. All right, and then I want you to do B. So for negative pi over 6, find a coterminal angle that's positive and a coterminal angle that is negative. And then don't go on to the reference angle part. I want to do that. Take a couple more seconds to set up this happens. Again, you should have 1 positive and 1 negative. All right, so what did we get for our positive value? Yep, 11 pi over 6, we agree. Okay, what about negative? That we got? All right, so once you find that you're adding 12 pi over 6, then you just subtract it. Negative 1 minus 12, negative 13. Negative 1 plus 12 is 11. Okay? All right, how are we feeling so far? Good. All right, the last thing we're going to do today is reference angles. Okay, now the reference angles we are going to extend to the radians, and we're going to be counting by radians. So to help you with this, the first thing we're going to do is just review what we talked about yesterday with the reference angle. So we're going to draw a little diagram about how we found the reference angles from yesterday. Okay, so when you are drawing your reference angle, you start with your value of theta, right? Okay, and we're just going to do theta here, an arbitrary value. When you are finding the reference angle, it is always the shortest distance to where? The x-axis. So the reference angle is the shortest distance. So write this down with me. The reference angle is the shortest distance to the x-axis. So, hi. Oh, no, it's okay. Yes, I will. Yep, bye. Okay, so this is going to be to the x-axis. It's always going to be to the x, okay, never to the y. Remember, it also has to be positive. And then do you guys remember the last thing it had to be? So it'll be acute, or in some cases, it can be the right angle. Okay. And then we're going to do an example together in radians. So your example is negative pi over 6. I want you guys to convert that to degrees. So when you're converting it, multiply that by what? Yeah. Okay, so your devices should be away and you should be doing this with me. Okay, so then once you cancel those out, okay, 180 divided by 6 is, yep, so this will be negative 30 degrees. Okay, remember that is the angle that we are graphing. Okay, so when you are graphing an angle that's a negative, still start at the same initial value. Okay, and then we are going to adjust 30 degrees. Again, I like to think of this, oh, I'm halfway here, so this definitely has to be less than halfway.
Teachers, please excuse the interruption. At this time, please release the varsity baseball and softball players for release.
Okay, so theta is equal to negative pi over 6. What we have to find is the reference angle. Okay, so your reference angle either is going to go from this terminal side to the positive x-axis or the terminal side to the negative x-axis. You have to find the shorter distance. Okay, so the shorter distance is either going to be, I'm writing up here on the smartboard, the angle in blue or the angle in red. Which one is shorter? Yes, the blue angle. So what is that? It's 30 degrees, yep. And what would that be in pi radians? Or sorry, in radians. Okay, so your reference angle is going to be pi over 6. Remember, your reference angle is always positive. Okay, so it's going to be pi over 6. This is the reference angle. Okay, so 30 degrees is your pi over 6 value. And when you're first doing this, you are likely going to think of it in degrees, okay? That is normal. You just have to write it in radians. So we're going to start thinking about, okay, 30 degrees is pi over 6. Okay, it's going to take some time to get used to that. So make sure you give yourself some time. Don't beat yourself up if it's not coming to you right away. This is going to take practice. All right, so for A, we're going to do 4 pi over 3. We are going to find the measure of the reference angle for each given angle. So I'm going to start showing you how to count by radians. This is going to be some important fundamental skills that are going to help us later on in the chapter. And when you're finding the measure of the reference angle, you are going to draw each angle. Okay, so we're going to draw the angle and then we're going to find the measure of the reference angle. So I'm going to show you a little trick for these. Okay, which is you can split up 4 pi over 3 into a multiplication problem. Okay, you can think of this as 4 times pi over 3, because isn't 4 times pi over 3 still 4 pi over 3? Yes. The reason why this is helpful is because you can start counting with radians, which is going to be very useful, okay? So what this means is we are going to go 4 times the measure of pi over 3. Okay, to find out what pi over 3 is, you can do your conversion. Some of you might start doing this conversion in your head because the pi's are going to cancel. And when the pi's cancel, you're just doing division. What's 180 divided by 3? 60. Okay, so what this means is we are going 60 degrees, pi over 3, we're going pi over 3, which is 60 degrees, 4 times. Okay, so I'm going to ask you to watch me the first time I do this, and then I'm going to give you time to do it on your own. So when you think of 60 degrees, okay, we should have a reference that when we do 60 degrees, it's about right here, right? This is about 60 degrees. Okay, if I were to do 60 degrees again, I know this is 90, right? Okay, so if I go another 60 degrees, I go 30 and then 30. So do you guys see that this would be 120 degrees here? And then if I want 60 degrees again, where would I end up? 180. And then if I went 60 degrees again, I'd end up at 240, okay, which again is 60 degrees. So what we just did is we counted by radian values, and then we are ending up here at this 240 degrees. Okay, so we are going to start at the initial value. We are going to end at that 240. And we are going to put that theta is equal to 4 pi over 3. This is our first step. Okay, so another way you can think of this is with your radians. That is what we are going to be doing. When I count this out, I normally am going to count it out below here in a circle to help me with the degrees. Okay, so here I wrote it in degrees, the 60, the 120, the 180, the 240. This is the same thing as saying 1 pi over 3, and then I'm going to 2 pi over 3. Here I'm at 3 pi over 3. Here I'm at 4 pi over 3, and that is where you are putting your angle. 3 pi over 3 reduces to what? Pi. So this is 180. 180 is pi. Okay, so this is how we're going to start counting. So I went pi over 3 4 times. 1, 2, 3, 4. 60 degrees each time. When you are finding your reference angle, it's either this angle, which we know is a no because you can't cross the axis. So your reference angle has to be here. Do we know what that is in degrees or radians? What is it? Yep, it'll be pi over 3, which is the same thing as 60 degrees. Okay, so this is pi over 3. Whenever it's given in radians, you are going to write your reference angle, okay, in radians. Okay, so your reference angle is pi over 3. All right, for B, we have negative 7 pi over 4. So do you guys think you can split that up the way I split up the 4 pi over 3 and find what the degree is of that radian value? Okay, so when you split it up, you have -7 multiplied by what? When you split this up, you have -7 multiplied by pi over 4. Okay, so that's really just the first thing I want you thinking about is, okay, if I have -7 pi over 4, that means I'm going 7 times in the negative direction of pi over 4. And pi over 4 is how many degrees? All right, let's convert together. So if we do pi over 4 times 180 over pi, if I'm doing 180 divided by 4, maybe instead, if I'm not using a calculator, I want to cut it in half. Half of 4 is 2, half of 180 is 90, half of 90 is 45, half of 2 is 1. So this is going to be 45 degrees. Again, I want you guys to watch me do the counting first, and then I will give you time to do it on your own, okay? So we're going to start by drawing a circle, okay, with a axis on it, okay? It's just easier to count because it's in terms of your arc length, all right? So it's in terms of your arc length. It's easy to keep track on here. So instead of going up, which would be the positive direction, I'm going to start by going down. So if I go 45 degrees, we know that's halfway, right? So that's a negative pi over 4. That's what I've done. Okay, now I have to go 7 times. So this is -1 pi over 4. If I go 45 more degrees, I'm here at -2 pi over 4. I'm not going to label every single one. We're just going to count together, okay? So this would be -3 pi over 4. This is going to be -4 pi over 4. I have -5 pi over 4, -6 pi over 4, -7 pi over 4, and that is where I'm ending up. So when I'm doing my angle, I'm putting it there. Okay, so I went 45 degrees 7 times in the negative direction. 1, 2, 3, 4, 5, 6, 7. Okay, so 1, 2, 3, 4, 5, 6, 7. So we're going to draw that angle on our grid. So it's 45 degrees, so it should be exactly halfway, which is nice when you're doing it with graph paper because then you can see the halfway. Just you can cut those in half. And then because it's negative, you start here and you circle around. Your theta value is -7 pi over 4. So to find your reference angle, sorry, I'll give you a second to draw. And then once you find your reference angle, it's always the shortest distance to the x-axis. So is it closer to the positive x-axis or the negative one? Positive. Yep. Yep. And then this is 45 degrees, which is what in radians? Pi over 4. Okay, so your reference angle here is pi over 4. So today, all of our reference angles are going to be in radian values. All right, and then for part C, we're going to do 14 pi over 5. So if I'm starting out the same way I started the other ones, for every single one, I just took the numerator and I multiplied that by pi over the denominator. Okay, so I took that number in the numerator and multiplied by pi over the denominator. So now I'm going to have to find out what pi over 5 is in degrees. So I know from doing these conversions that I'm going to end up taking 180 and dividing it by 5. And I know 5 goes into 180 because why? Yeah, it ends in a 0, right? Okay, so if I do, how many times does 5 go into 180? 5 goes into 18. 3 times, yep. We have 15. 5 goes into 30. 6 times. Okay, so pi over 5 is 36 degrees. Okay, now counting by 36 degrees 14 times sounds like a lot of work, right? So let's do a shortcut. Okay, so when you are working with these bigger numbers, think about what one full rotation is. We know one full rotation is 2 pi. So if the denominator is 5, what would we call this? What would 2 pi be with a denominator of 5? Yep. So see how this would be 10 pi over 5, how that's equivalent to 2 pi? So one full time around is already 10 pi over 5. So now all I have to do is count up to 14. Okay, so instead of doing the full 14 times, we've already done 10 times. Okay, so the 11 pi over 5 is going to be at this 36 degrees. And you guys can just estimate. I'm really just looking to see it's in the right quadrant. So that's 36 degrees. What's 36 plus 36? 72. So that's still in quadrant 1, right? So that would be 12 pi over 5. Okay, what's 72 plus 36? I got 108 when I added. Okay, so 108 is past 90 in quadrant 2. So I have 13 pi over 5. And then 14 pi over 5 is 108 plus 36. So 14, carry the 1, 144 degrees. Okay, so that's going to help me map that out. If I know this is 180, okay, then 144, the distance there is what? What's 180 minus 144? 36. Okay, so when I'm drawing out my angle, I know halfway is 45. Okay, so 36 is about 10 degrees lower than that. And again, it doesn't have to be perfect. It should just be a reasonable estimate. And remember, you did a full rotation. So when you're drawing the angle, we're starting here. You do a full rotation, and then you have that coil. Okay, so when you are finding your reference angle, we know from here to here, this is 180, this is 144. So if the distance is 36 degrees, we've already calculated that that's pi over 5. Okay, so that is going to be your reference angle. Yeah, just make sure you look at. Okay, so for your homework assignment, you have it on 2 pages. I'm going to have you write it down, and then I'm going to put up the book for you.